Hello, good afternoon. Welcome back. Today we're gonna start new module number 3. It's on three-phase transformer. So there will be 2 lectures for this module, lecture 8 and lecture 9. Let's start with lecture 8 today. So there were 2 experiments that we're gonna conduct today. Delta delta and YY connection. So yeah, let's start with experiment number 8 first. Okay, so before doing that, I think I should cover some three-phase transformer theory part. So I'm not gonna go into much details because you've already learned about this. So any three-phase connection is actually owned in such a way that it has two distinctively um, different connections. One is called delta connection, another one is called Y connection. So three-phase transformer bank allows the voltage in three-phase AC power circuit to be stepped up or stepped down. So we all know this, but in today's example, we'll see how we can use the concept of three-phase in a transformer, and we connect a three of single-phase arrangements to make it to a three-phase arrangement. So let's go to, and I guess you all know for delta circuit how the voltage, phase voltage and line voltage, they are actually connected, and what's the relation between these two. So yeah, I'll be explaining everything to you guys, and um, so yeah, let's go to the other lecture which has a table. So let's focus on single phase transformer first. So this is one single phase, this is another one, this is another one. Say for example, this is phase A, this is phase B, and phase C. So in like in this case, so you'll see in each transformer has two windings. Winding A, which is primary side, and this is winding B, which is secondary side. So on the primary side, we have two leads. One is, say for example, this is A and this is A prime. This is B, this is B prime, and this is C, this is C prime. So in order to have a delta connection, we need to connect these A prime of A and B. So we'll connect these two and these two. So basically, we're gonna connect this and this, and we'll connect these. So that will make a del connection on the primary side. So we'll have to do the same if we want a del connection on the secondary. We need to actually connect these two and these two and that two. So on the primary and secondary, we have now with this arrangement we have del connection. But what if we want to have Y connection? Let me erase everything. Let me check how do I. Okay, here drawing. Okay, so now let's draw a Y connection. In Y connection, like I told you that this is A and this is A prime. That's an like assumption. Okay, so all primes, like for instance, this is B, B prime, C, C prime, all primes or all A's needs to be connected to have a mutual point, like junction point, you can say. So in that case, I will have to connect this with this and this with this, and this will be A phase, this will be B, and this will be C. So if I want to do the same for the secondary side, what I'm gonna do is I'll connect these two and I'll connect these two. So all have a junction point, and these three leads, the actual leads, these will form another like output. So that's for the Y connection. So those are my very poor drawing, but let's go for the next one. Next page. So this is the Y connected transformer's primary side, and this is the Y connected secondary side. And this is Dell connected primary side, and this is Dell connected secondary side. So for Y connected, you'll see that there's a junction point where all the primes come together and meet at this point. So this is also called neutral. So the voltage between from A point to the neutral is called phase voltage. And if we consider from A point to B point, we'll name them line to line voltage. So what happens is, so the amount of voltage of in Y connection, the amount of voltage between line to line, this line to this line, is larger than the amount of voltage between these phase. So this is phase voltage, and that is line voltage. So line voltage for star connection, star is another name for Y connection. So for star connection, phase voltage is lower than, so it's lower than the line voltage. So it's √3 times lower, and line voltage, that means line voltage is √3 times larger than phase voltage. So but in case of current in star connection or Y connection, they're the same. Phase current and line current, they're the same. But for Dell connection, the phase voltage and line voltage, they're the same. Let's see. So this is one phase. So the phase voltage should be from this point to this point. And we can see the line to line voltage is also this point, the same point. So for Dell connection, phase voltage and line voltages are same, but the current is different. So say let's say the current is incoming here at A branch. So current is going through this line, and it's divided into two sections. So the line current is this IA, and phase current is divided between this, like say for example, this is C and this is A. So it's split between A and C. So phase current is smaller than line current. And what is the ratio of that one? So it'll be √3 times, or √3. We'll divide it by √3 or multiply it by √3. So that's all for the theoretical part. Now I'll talk about some other connections. Like let's talk about Dell connection. For the primary side, it could be this way also, but we are not, today's class, we are not going to talk about this, talk about this topic. These two topics will focus more on these two. Anyway, so I will provide this table and these files, these two files, so that you can have a complete table and diagrams. So Now what I'm gonna do is I will show you two video clips where I demonstrated two Dell connection with load and to Y connection with load. So the primary side will be Y connected and the secondary side will also be Y connected and the load is also Y connected. For this first case, it will be Dell, Dell, Dell. So let's go to the experiment manual, experiment manual number 8. It's talking about Dell to Dell connection. So here, if you look at the schematic diagram, circuit diagram here, so this is one Dell connection, this is another Dell connection, this is for the primary side and this is for the secondary side. But here it is showing that it's used different type of load, but we are going to, so in here what they are showing that they're using Dell connected load as well. So we are going to use only R load. We are not going to use anything other than R load. So we are not going to change resistance, the value of resistance. We are going to stick with one resistance value and we will perform it. So let's see the video for that one. Let me open the video first with the Dell connection. Hello. So I will be talking about the demonstration of delta delta connection now. So we are now this is the first demonstration of three-phase transformer. So we have one single phase here, another single phase here, another single phase here. So this is phase A, this is phase B, and this is phase C. So if we look at phase A, the primary side first, so it starts, the starting point is H1, the end point is H2. So I'm gonna call this A and this is A prime. So for B, it will be B and B prime. This is C and C prime. So for delta connection in particular, so we need to connect the prime to the actual. So say for example, this is A and this is A prime, this is B and that is B prime. So we need to connect A prime to B and B prime to C, and this C prime needs to be connected to A. So this yellow cable is doing the connection. So now if I look at this figure, I can see that the H1, this H1 is this point. So if this is phase A, this is phase B, and this is phase C. And same for X, Y, and Z. Since we are going to actually do delta delta, so we need to actually follow the instruction given by this page. So we'll have to connect like H1 to H5 of the second one. So again H1 to H5 of the second one. This is what I just did. Like, so H5 of A and H1 of B needs to be connected, and H5 of B needs to be connected to H1 of C. Same goes for H5 of C needs to be connected to H1 of A. If we do this, we'll get these sorts of connection. Same goes for the secondary, because we are dealing with delta delta. So I have connected everything like so, and so the power supply will be coming from this power supply unit. So we have A phase, B phase, and C phase. So this A phase is connected directly to the H1 of A. So B is connected to H1 of B, and C is connected to H1 of C. Now if we look at the load here, so
Load also has a b c arrangement, since we need to actually use three-phase connection. Now let's see the connection. So A prime is connected to B, and the B prime is connected via this red cable to C, and this C is connected to C prime is connected to A. And from the transformer's secondary side, let's connect this one. So this is transformers X is connected to loads A. That means, so if I look at this figure, so this is, say for example, this is A is connected to one of the loads here. So although this figure, I'm gonna share one figure which will actually represent the exact figure. So A of the secondary, which is this red color, okay, banana cable, is connected to the A of load A, and same goes for the B section, Y. This is Y. If this is X, this is Y, and this is Z. So this is the primary, which is A phase, and the secondary is X phase. So this is phase B, this is the secondary is phase Y, this is phase C, and the secondary of the third phase is Z. So from Z, if we look at this connection, so I'm connecting this cable to this C portion. Okay, so the connection is right, but with this arrangement I won't be able to actually measure anything. So we need to measure the voltage supplied for one of the phases. If I look closely, so I can actually, since the supply is A, B, and C, I can actually measure one of the line to line. So for delta connection, I guess you already know that for delta connection, the line voltage and phase voltages, they are same. So if I calculate, if I measure a voltage along this point and this point, then I'll be able to actually measure line to line voltage as well as phase voltage. So for that reason, I need to use this power analyzer. So let me connect it. So I'm gonna remove this connection. So I will connect A here and B there, and from this power analyzer I'm gonna take this cable and I will connect. This is A, it's going there, and B should go to the B phase. Okay, so that is the connection for the primary side. Now I will do the same for the secondary side. So I'll remove this one from here to there. I'm removing from there this X phase, and then I'm gonna remove the Y one also. So I'm removing, I'm gonna connect this X and Y to my analyzer here, and from this analyzer I will connect to the load, which is should be connected to this A load and B load. So I will be turning on the supply right now. Let me turn on the supply. Let's turn this on, turn this on as well. Let's turn this on, let's turn this on as well. So we will check only 5 or 6 values. So initially we'll see the, in this case we will actually talk about we'll be actually calculate only the voltage and primary side's voltage, supply voltage, and load side voltage. So let's increase the amount of voltage to say for example 25. So I'm increasing the amount of voltage here, which is 25. Because of the reflection it's hard to see. Okay, from this angle you can see that the supply voltage is 25. Okay, 26.2. For that case we are getting 12.8. so in both cases these voltages are line to line voltage or phase voltage. Now let's increase the voltage to 50. Okay, so this is 50.8 and the secondary value is 24, so it's half. So it should be like this. Let's increase it to let's say 100. Yep, so 100.1.4 on the secondary. We have 49.2. It shouldn't be exactly 50 because there are some losses. So that's about it for the delta connection. Now after that we'll study Y to Y connection.
Yeah, that's the demonstration part. So what you'll have to do is, for delta connection, you'll have to calculate using you use a table. There are three values that are given you. One is I supply 25 volts, 50 volts, and 100 volts. So you need to calculate is it called the phase voltage, line voltage, phase current, and line current. You could see the current values provided over there as well. So you need to actually, for delta connection, you need to calculate phase voltage, line voltage, phase current, and line current. Okay, very simple demonstration. You need to in your report, what you'll have to do is you need to provide there will be two-part report because I'll be also explaining you about Y connection. So this is delta connection. So you don't have to put in the report, you don't have to put too much. You need to write down the purpose, then the scheme, all the figures here, procedure, and some question answer that are given here, and schematic of this. This is the schematic that I want you to draw. That's it. You don't have to do anything else, and definitely you need to put this table after both of the experiment part A, part B. You need to provide a table where you need to show three voltage levels and with three voltage levels like 25, 50, and 100. You need to provide the line voltage, phase voltage for primary side and secondary side. You need to make a table by yourself where on the left hand side you will have line voltage of the primary side, line phase voltage of the primary side, phase current of the primary side, line current of the primary side. On the right hand side, you'll have to give me phase voltage, line voltage, phase current, and line current of the secondary side. So you need to provide two tables, one for the delta connection, another one for the star. Now I will show you another video for the Y connection.
Hello, so this is the demonstration of this arrangement, which is Y. So the load will be Y and the secondary side will also be Y connected, and the primary side will also be connected in Y form. So I've already done the connections here, so let's see how it works. So if I look at this graph, look at this figure, then we can see that all H5s, so one winding starts from H1 till H5, so in case of like say for example, this is A, this is B, and this is C. In three of them, they have a common point, so that's connected. They're connected H5 of each of the lines. So we are gonna do the same. So H1 should be connected to the load, not to the load, supply, and N should be connected to the neutral, and another point should be connected to B, and the final one should be connected to C. So I have done this like so. Let's see, this is A, this is B, and this is C. It's going directly to A phase, B phase, and C phase. So I have color coded so that we understand, because we are using a lot of cables, so I'm actually using all in so that I can understand which one is what. So this is red, that means it is A, this is blue, this is B, and this is C is green. Same for XYZ also. So X is blue, sorry, red, Y is blue, and Z is black. So same for the load as well. So since all of them are Y connected, I'm gonna explain one. I will explain the load also. Like so, from the figure we understood that one of the points should be common for all. Say for example, for A phase we have common connection, which will be H5 in this case. So H1 is the main connection and H5 is A prime. So so this is A and this is A prime. So all primes, like for example, for B phase, B prime is H5. For C phase, H5 is C prime. So all primes will be all primes are connected all together. So this is going there and this is going there. So we have three connections all together, and this needs to be connected to the neutral. So we have connected neutral to the what is it called, the common points, neutral of the Y. So in Dell connection it's not like this. In Dell connection we don't have any neutral, but in Y connection we have neutral. So we use the same formulation for the secondary side. So this is X, this is Y, and this is Z, and all the primes are connected here at this point. Now the interesting thing about this is we can actually connect the neutral of the secondary to the neutral of the load, because since they are also connected in what is it called, Y fashion. So this prime of A, prime of B, and prime of C, they are connected to each other, and this is also connected to the secondary's neutral. So this is the neutral of the load, so this is connected to the neutral of the secondary, and this A, B, C are coming from the secondaries X, Y, and Z. They're connected. So in this demonstration I will show you in both cases. I will actually measure the line voltage, which is this much, like A to B or B to C or C to A, and at the same time I will also measure from A to neutral, which is phase voltage. So this much is phase voltage and this much is line voltage. So I will take I will connect this. Initially the connection is such that we can only measure the line to line voltage. After that, once we are done with this, we'll measure line to line current. Okay, not line to line current. Line to line current will be measured, but after that we'll be measuring the phase voltage of both primary and the secondary side. Okay, let's start the circuit. I am turning this analyzer on and this one on as well. So let's supply with 25 volts. So let's see, the supply voltage is 25, so it is 26.9, and the secondary is 13. Okay, now let's increase the amount to 50 volts. So this is 49.8, and the secondary voltage is 24.3. Now let's increase the amount to 100 volts. So this is 100 volts, and the secondary voltage is 14.8. Now I'm gonna actually change the connection such a way that we can measure the phase voltage. So I'll take some time for that. So I have changed the connection. Let me go through it. So one of the phase is connected to the power analyzer, and this neutral is also connected to this power analyzer as input, and the output is going to one of the phases, which is A phase, because this is A phase connection. So this is A phase, and this green wire, which is the ground, not ground, neutral, so it is connected to one of the neutrals of the three-phase primary side. And same goes for this load side power analyzer. If I look at it, so this X is coming, the X is this one, so this is coming to the power analyzer, and the this neutral of the secondary is coming also. So, and we are feeding this to this load. So one of the that red banana cable is connected to A phase, and the green one, which is the neutral, is connected here. So why is the connection like this? In order to so that we are taking this point, so this is A and this is the neutral, so that we can actually measure phase voltage. So let's turn this on. I'm switching them on. Let's go for 25 volts. So that's 25.8. So this is 12.6. So 25.8 and 25.8, and the secondary is 12.6. So that's half. So let's go for 50 volts, which, so this is 49.8. On the secondary we'll see 24.3. Now let's go beyond. So let's go 100 volts. So that's 100 volts, and we have here on the secondary 49.3. So I'm gonna again change some parameters. In some on the primary side I will connect the power analyzer where we can actually measure the phase. So I'm not gonna change on the primary side, but on the secondary side I will measure line to line voltage. Okay, let me change it. So I have changed the connection once again. So on the primary side, red and greens are connected. That means we are measuring the phase voltages. So that means these voltages, I have not changed anything here, but here I have changed from green to blue. That means from X and Y we are connecting these two. That means XY phase are here, like line to line voltage, and from here I am actually supplying to the load. So let's start the circuit once again. Let me turn on the power analyzer. Let me switch the voltage up. Let's go to 25 volts first. So that's 25.3 volts. Since this is the primary, which is high voltage side, and the turns ratio we know for this machine is 1 to 2, so sorry, 2 to 1, so that means we are supposed to get 12, but we are not gonna get 12 in this case. We got 21.3 because in here we are getting what is it called, we are getting line to line voltage, so it's root 3 times of 12, which is 21.3. so if I increase the voltage, so if I increase the voltage to 50, so 53.4, I'm supposed to get less than 45, but I'm getting 45.1. So so I'm not gonna go beyond this point. I'll go to 75 volts. Okay, so this is 75.9 on the primary side, so on the secondary side it is 64.1. so yeah, that tells us that the supply voltage, even if it is like 75 and the turns ratio is 2 to 1, so we are supposed to get half of it, just because we are measuring line to line voltage on the secondary. We are getting a higher amount of voltage than the primary, since we are measuring only the phase 1. So that,
So yeah, I have already explained everything. So all you have to do is you take a note on those like values, like current value and voltage value. We don't need power factor or the power for this case. All you have to do is measure those, like take a note of those measurements and calculate based on these formulas. In case of Y to Y, I have already actually, in one case I have measured phase voltage here on the primary side and line to line voltage on the secondary side. So that's why the values were a bit different. So I want you to calculate everything, and it'll be a two-part report. One part will part A will cover delta delta connection, and part B will cover, let me see, Y to Y connection, which will be given in experiment number 9. So this is a very simple experiment. So I hope you will not have any or not face any problem. And thank you so much.